Welcome to the Forces Part 2 tutorial. So in Part 1, we talked about electromagnetism and the three subforces that we can use to describe it. In this tutorial, we're going to talk about gravity, and gravity is actually a really fascinating force. So you've probably heard that Sir Isaac Newton invented gravity, and you've probably seen pictures of Isaac Newton, drawings or representations, because they didn't have photographs back then, that look something like this. And usually the story is told about him sitting under a tree and an apple falls on his head and he goes, "Aha, gravity." Of course, that's a little bit silly, right? Obviously gravity existed before Newton noticed it, and people had been noticing gravity for a long time. But what Newton did was he actually described the behavior of gravity and created a law. Remember that law was one of the vocabulary words on your science, nature of science test. So a law is an important observation, and it's a description of what's happening in reality. So all Isaac Newton did, and it was a big deal, was sit down and figure out what exactly happens when something's under the influence of gravity. And he actually figured out that all things are kind of under the influence of gravity, including not just the apple, which is drawn to the ground, but our moon, which is attracted to the planet Earth, and the planet Earth, which is attracted to the sun. And he was really the first person to realize that all of those things were the same force, and to call those forces gravity. His law describes gravity this way. He says, and if you can look at these pictures in order with me, he describes gravity like so. He says that, if you look at these pictures right here, the force of gravity acts between all objects. This is not easy to notice because gravity is such a weak force that you can only feel a gravitational field when there's a very, very massive object near you. So we notice that the Earth exerts a gravitational field on us, but the Earth is huge. That's why we notice it. However, Isaac Newton was able to realize that everything has its own gravitational field, including the apple, which was falling from the tree. And he would even have said that tiny things like dust particles have their own gravitational field as well. They're just tiny little gravitational fields that you can barely feel, kind of like weak magnets. So the more massive something is, the more gravitational pull it has. And that's his second observation, that if the mass of something increases, the force of gravity increases. Now, most students think mass and weight are the same thing. They're related to each other, but they're not exactly the same thing. But for right now, it's okay if you want to think of mass as being like weight. The third thing that he noticed was that if the objects get further apart, gravity is lessened, and if the objects get closer together, it increases. And again, these are not easy things to observe here on planet Earth, because generally speaking, the Earth itself is the gravitational field we're experiencing, and we don't tend to get very far away from the center of the Earth. Even if we're on top of a mountain, statistically, you're not that much further away from the center of the Earth at the top of a mountain than you are down in a valley. He actually calculated out mathematically the force of gravity, and here's the crazy looking equation. You don't need to memorize this equation, but it's good to realize that many laws in science boil down to numbers. You can actually calculate something for a lot of laws. So you can calculate the force of gravity. All you need to know is two pieces of information. You need to know that you need to know how far apart the objects are, so the distance between them, and you need to know their masses. And with those two pieces of information, you can calculate the degree or amount of gravitational force between the objects. So describing gravity using Newton's law is useful. We can calculate all kinds of things using that, including how to send a spaceship to the moon. All sorts of things. It's very useful, that equation. However, it doesn't tell us why gravity happens. And it took a really long time after Newton before somebody was able to come up with a theory to explain the law of gravity. So we knew that, things, you throw something up in the air, it comes back down to the Earth because it's attracted to the Earth. But we really didn't have a good explanation of why. And this is a black box, right? Gravity is, in a way, kind of invisible to us. We know it's there, we can sort of feel it, but what's causing it is really hard to figure out. Well, Einstein came up with a theory of gravity that is still in use today, and it has a lot of evidence to support it, very similar to the types of evidence that we got from our black box when we investigated our black box, first we described what happened when we poured water down the funnel when it was in different positions. Then we moved on to trying to explain why we saw those things. And that's the theorizing part. That's where we try and develop theories to explain our observations. Einstein didn't have the ability to really investigate the problem, even indirectly, but he had something very powerful. He had a great imagination. And Einstein is probably most famous for what are called thought experiments, where he doesn't actually do any physical experimenting, but he takes an idea through his imagination until he understands it better. And here's what he proposed as a possible explanation for gravity. He said that when you take an object like the planet Earth and you put it in space, its mass actually warps and curves space around it. And because we can't see space, we can't see this warping, but we can detect it as a gravitational field. So the picture that I'm showing here on the right is trying to show you that when you put something that's really massive, really heavy, in the middle of space, the space around it gets sort of crinkled up and condensed. It warps or curves. Let's look at the same idea, but instead of showing it in 3 dimensions like that previous picture, let's just look at it in 1 dimension. So what you're seeing here is a picture of space that's warped beneath the Earth. It would be warped on all sides of the Earth, but I'm just showing you under the Earth so you can visually recognize what's happening here. Einstein said that what gravity is objects that get caught in these little dents that are created. So this dent that the Earth is making is what he called a gravity well. So he would call this a gravity well. And the bigger the object is, the more massive it is, the bigger that well is. And here's our moon, and you can see the moon is sort of falling into the gravity well of the Earth. And it would just roll down and fall against the Earth, just like you do, or just like that apple does. But the moon actually has its own velocity because it was set in motion long ago during the Big Bang and during the formation of the universe. So the moon is actually shooting off, trying to go off on its own, and then it gets pulled into the gravitational pull of the Earth and winds up staying in orbit. So there's 2 forces at work there. The original force on the moon that sort of ejected it out into space and it was moving in a straight line. Then it encountered the gravity well of the Earth and it starts to sort of roll around the rim of the Earth's gravity well. Likewise, the Earth is rolling around the gravity well of the Sun, as are all the other planets. And Einstein said that the more massive an object is, the deeper the gravity well is. And the further away you get the 2 objects, the more shallow the gravity well becomes, right? So you can see that right underneath the planet, that's the deepest part of the gravity well. But out here, it's a gentle slope. And this is why, as you get further and further from the Earth, gravity seems to be less and less. And Einstein would say, all objects have gravity wells, including a particle of dust, but they're tiny, and so other objects don't really roll down into them. So you might be wondering, well, how am I going to quiz you on this information? Here's what I want you to think about for your quiz. Because the part 1 part of the quiz is going to be about the different types of electromagnetic force and recognizing what force you're seeing in a picture, right? So you'll have different arrows in pictures, and they'll ask you, well, what force do you think this is? Is this friction? Is this the normal force, or is this an applied force? And then I might also ask you, where you see gravity in the picture. But the last part of your quiz is going to be basically a question about this. I want you to compare the words law and theory, and I want you to use gravity to do that. And this is actually a very higher level thing that I'm asking you to do. You need to understand the difference between a scientific law and a scientific theory. A law describes your observations, and a theory attempts to explain those observations. So I want you to be able to explain back to me how Newton described gravity. So he had basically 3 observations about gravity, and I want you to think what those 3 observations were and be able to explain them. And Einstein said, well, here's why we see those 3 things. And he explained it with his gravity well theory. So what you need to be able to do is compare those 2 things or line them up with each other, sort of the way we did with our black box lab, where first you made observations and then you tried to explain each observation. So an example of pairing up an observation with an explanation would be something like, in the black box, when we turned the funnel to the right and poured down 20 milliliters of water, it came out 17 milliliters of water dyed red. That's your observation. Your explanation might be that there is a tube leading away from the funnel that leads to some kind of powder that is in some kind of filter, and the water runs over the powder. Some of it gets dissolved, some of it gets absorbed into the filter, and then it runs out, and so you get colored liquid being dyed by the powder, and there's less than you started with because some of it was absorbed into your filter. That's an explanation. So what you want to do is you want to match up Einstein's theory, his explanation, with the observations that Newton made. And that's pretty higher level, so you need to think carefully about that and be ready to do that on your quiz. Okay, that's it for Forces Part 2. I'll see you guys in class.